Welcome to week 3, where we will be discussing the atomic nature of matter. Specifically, we will be looking at the different forms of matter, solids, liquids, and gases. First, we're going to look at the characteristics of atoms. An atom is defined as the most indivisible object of matter. In this slide, we see that an atom is a particle that makes up a substance. It's very important to understand that atoms come in the form of elemental substances. This means that an element is composed of only one atom. The most common one, and the easiest one to remember, is hydrogen. Hydrogen gas, or H2, exists as an element and as an atom. To date, there are 115 elemental substances known, of which 90 occur naturally in nature. You can find all of the atoms or elements on a periodic table located in any chemistry or physics book. Some characteristics of atoms: they're incredibly small, they're numerous, they're perpetually in motion due to their neutrons, protons, and electrons, and they're ageless. A molecule is defined as two or more atoms that are bonded together. When atoms combine and bond, they may bond in two ways: a covalent or an ionic manner. In an ionic manner, where electrons are actually donated or received, the atoms themselves in the solid are arranged in a regular array, which is known as a crystal. If there's not a regular array, this is called an amorphous solid. One of the common examples of crystal structure occurs with sodium chloride, NaCl. There are alternating sodiums with chlorines that form cubes that may grow or be shrunk. However, they are still crystalline in structure. Next, we're going to be looking at density. Density can be defined from some terms that we have examined in week 1 and 2. Density is known or calculated as mass over volume. Mass we measure in kilograms or grams, and volume may be measured in meters cubed or centimeters cubed. So the density units are kilograms per meters cubed or grams per centimeter cubed. Density is dependent on a few things. One of them, of course, is the mass of the atoms, and then the other is the spacing between the atoms. Elasticity is another important concept for week 3. An object subjected to external forces may undergo changes to shape or size. As the slide says, a body's elasticity is a measure of how much it changes when a deforming force is exerted on it and how well it returns to the original shape. To our right, we can see Hooke's Law by Robert Hooke, 1663. Hooke's Law explains that there is a force that is needed to extend or compress a spring. This is given by the formula F equals K delta X, where that force is given by multiplying K, the constant, by delta X, the change in distance. Another property of Hooke's Law that's very important is that the force needed to extend a spring is also equally negative to a force needed to compress a spring. Pressure. Pressure is defined as the force per unit area that one object exerts on another. As an equation, pressure is equal to force over a given area. The example on the right is commonly used to define and explain pressure. In the diagram, we can see that the individual is laying on a bed of nails. This probably consists of thousands of nails. That makes a very great area. If the individual was placed on 10 or 20 nails, this would change the entire picture. The pressure would be greater because the force per area, with the area being less, would be much greater than before. In this example, the teacher lying on the nails is unharmed because the force is applied over many nails. Another concept we're looking at is buoyancy. Buoyancy is a concept when dealing with solids that float or are partially immersed in liquids. It is important to understand that the liquid must be static or not moving. The definition of buoyancy is the force that acts upwards against the boat. As with other forces, the standard unit of buoyancy is the Newton. An important concept of buoyancy is that a completely submerged object always displaces the exact volume of liquid equal to its own volume. We are also looking at atmospheric pressure and the barometer. Atmospheric pressure is caused by the weight of air. Of course, this changes from one region to another. It is never uniform. Measurements of atmospheric pressure can be done by a barometer, and it can be used to predict weather conditions. Last, we are looking at Boyle's law. Boyle's law uses the main equation that we look or analyze gases by, PV equals nRT. When we hold the other constants equal, pressure and volume is found to have an inversely proportional relationship. What does that mean in common or layman's terms? If you double the pressure on a gas that is enclosed, the volume will be half. It is directly inversely proportional. On the other hand, if you half the pressure or you decrease the pressure, the volume of the gas will expand to double. I'd like to thank you for participating in week 3. We look forward to your submissions and hope that you have learned quite a bit of the concepts that are required for successful grades in physics.